we have studied an interesting example of reactive intermediate, Carbanion. First step is the introduction, just definition of Carbanion. Yes, it is trivalent, negatively charged carbon species having 8 electrons in its valence shell. Also about the properties of Carbanion. Then second point is the structure of Carbanion. Third point is the generation of Carbanion, how it is generated. Now, next step is very important step is the stability of Carbanion. Stability means we are going to discuss some important concept related to the stability of Carbanion. Mainly, there are 3 concepts which affect the stability of Carbanion. One is the inductive effect, then second one is the resonance effect. Also, there is aromaticity. This different concept helps to explain the stability of Carbanion. Now, let us see how inductive effect influence on the stability of Carbanion. Okay, I will take a very simple example. So, this is the methyl Carbanion. Carbon having 3 hydrogen atoms. There is a negative charge on the carbon. Yes, it is example of Carbanion. Consider one more example. Suppose one hydrogen. I have replaced one hydrogen by one fluorine atom. Now let us see stability of that Carbanion. Now here we know that fluorine is more electronegative than carbon. Therefore, it shows electron withdrawing inductive effect. This shows minus I effect. Fluorine is more electronegative than carbon. Hence, it shows electron withdrawing. म्हणजे या बॉन्ड मध्ये असणारी जी इलेक्ट्रॉन पेअर आहे ती थोडीशी स्वतःकडे तो ओढतो, फ्लोरीन ओढतो, and this is called as the minus I effect. What happens due to this? Okay, now in our Carbanion, central atom is carbon. Carbon having negative charge means central atom is electron rich. It is electron rich, and suppose that fluorine withdraws electron from the central carbon, then that Carbanion becomes stable, and therefore this Carbanion is more stable than methyl Carbanion. ठीक आहे, आपण आणखीन एक्झाम्पल बघूया. सपोज 2 hydrogens are replaced by 2 fluorine. This is a difluoro methyl Carbanion. Now it having 2 fluorine atom. Therefore, both the fluorine atom having minus I effect. They withdraws electron. There is a more minus I effect. There is a more minus I effect. Hence, it is again more stable than fluoromethyl Carbanion. Suppose another example. Here again there are 3 fluorine atoms. All of them are having minus I effect, and therefore this is having again more stable than remaining one. Okay, this is just about the influence of minus I effect on the stability. But simply आपण असं म्हणूया, as minus I effect increases, the stability of Carbanion increases. Okay, consider one more example. Okay, this is the example of primary Carbanion. Now here I have replaced one hydrogen atom by one methyl group, and we know that all the alkyl group, this shows electron donating inductive effect. This shows plus I effect. This methyl group donates that bonded electron pair towards central carbon. Already central carbon is electron rich. In Carbanion, central carbon is electron rich. It having more electron density, and therefore when any alkyl group which donates bonded electron pair towards that central carbon destabilize that Carbanion, and therefore this Carbanion is less stable than methyl Carbanion. Let us see one more example. Now here there are 2 methyl groups, and both are having plus I effect. There is electron donating inductive effect. There is more plus I effect. Hence, it is again less stable than primary. तो आणखीन primary पेक्षा less stable असेल. Consider the example of tertiary Carbanion. Here there are 3 methyl groups. Means again there is a more plus I effect. And it's just a plus I effect already. Central carbon having more electron density. आणि आणखीन जर त्याला alkyl group आपण जोडले, जे इलेक्ट्रॉन देता, मग त्याची आणखीन stability कमी होते. And thus tertiary Carbanion is again less stable than primary and secondary. Okay, this is just about the influence of inductive effect on the stability of Carbanion. As minus I effect increases, stability also increases. While as plus I effect increases, then the stability decreases. This is about the inductive effect, how it influences on the stability of Carbanion. Now let us see second, resonance effect. We know that what is meant by resonance? Yes, delocalization of electron in the conjugated system. We know that if any species show the delocalization, if any species show the resonance effect, then it becomes stable. Let us see a very simple example. Yes, it is active methylene compound. This is the Carbanion. Now, this is Carbanion having electron withdrawing group at neighboring position. This is ester group. Yes, example of electron withdrawing group. This is another ester group. Example of electron withdrawing group. Now here, there is a negative charge on the central carbon. Means there is an electron pair. Now, this electron pair delocalized in the electron withdrawing group. It delocalized in the ester group and we get resonance effect. We get resonating structure. Okay, this electron pair form a pi bond between these two carbon. Therefore, to maintain the valency, this pi bond undergo breaking and electron pair goes on the next oxygen. Okay, this electron pair goes on the oxygen and we get the resonating structure. Now here there is a double bond, here single bond, oxygen having negative charge. Okay, this is the resonating structure for this particular Carbanion. Okay, now let us see one more possibility. There is one more possibility. This electron pair can be delocalized in the second ester group. या ester group मध्ये सुद्धा त्याचं delocalization होतं. How it is delocalized? Here, this negative charge form a pi bond between these two carbon. Now, to maintain the valency, next pi bond undergo breaking. This electron pair goes on the oxygen and we get the another resonating structure. Now here there is a pi bond and here there is single bond and oxygen having negative charge. This is another resonating structure. Actually, these resonating structures of Carbanion are called enolate ion. And we know that if any species, any Carbanion show the resonance effect, there is a delocalization of electron. Therefore, that species becomes stable. That Carbanion which is formed from active methylene compound also shows the resonance effect. There is a resonance effect, there is a delocalization of electron, hence it is more stable. Let us see one more example, very interesting example. Okay, this is benzyl Carbanion. To the adjacent position of negative charge, there is a conjugated system. There is alternate single and double bond. And therefore, this negative charge, this electron pair can be delocalized in this conjugated system. Means it forms a pi bond between these two carbon. Now to maintain the valency of this aromatic carbon, one of the pi bond undergo breaking and this electron pair goes on the next carbon. Okay, and thus due to delocalization, there is a formation of pi bond between this carbon of CH2 group and carbon of aromatic ring. आणि याची व्हॅलन्सी मेंटेन करण्याकरिता इथला पाय बॉन्ड ब्रेक होतो and this electron pair goes on the next carbon and now it acquires negative charge. While this carbon acquires negative charge and we get the resonating structure, we get the canonical structure for the benzyl Carbanion. Now that cyclic carbon having negative charge means there is electron pair, it again undergo delocalization. And here this electron pair form a pi bond between next two successive carbon, and to maintain the valency, next pi bond undergo breaking and electron pair goes on the next carbon, and now this next carbon acquire negative charge. Here there is a new pi bond, while here there is a negative charge on the para position, and again this electron pair undergo delocalization. इथला pi bond तयार करेल, इथला pi bond break होतोय, this electron pair goes on the next carbon. Okay, here this is the new pi bond, while this carbon acquires negative charge and we get another canonical structure for benzyl Carbanion. So here again there is a possibility of delocalization. This negative charge form a pi bond between these two carbon, while this pi bond undergo breaking, this pi bond, next pi bond undergo breaking, electron pair goes towards carbon, this electron pair goes towards its original position, and then there is a formation of last resonating structure for the benzyl Carbanion. And thus in benzyl Carbanion, negative charge from the carbon, that is electron pair from the carbon, delocalize in the conjugated system, and we get number of resonating structure. Here, number of resonating structure is more, hence this species is again more stable. Now let us see one more important concept, aromatic carbanion. If molecule is aromatic, if any species is aromatic, again it is more stable. Again it is more stable. Consider a simple example. Okay, this is cyclopentadienyl anion. This is the example of carbanion because carbon having negative charge. This is cyclopentadienyl anion. Okay, now in this cyclopentadienyl anion, there are totally this pi bond having 2 electron, it having 2 electron, and this 2 electron from the negative charge. Means totally there are 6 electrons, and that 6 electrons are delocalized in the 5-membered ring, and therefore there are Furion plus 2 pi electron. This particular species is a cyclic. It is planar, and there are Furion plus 2 pi electron, that is 6 pi electron, and delocalization is also maximum. Hence, that cyclopentadienyl anion is the most stable. It is most stable carbanion, and this is due to the aromatic stability. This is due to the aromatic stability. Okay, this is about the actually influence of aromatic nature and how actually that species, that carbanions are more stable due to aromatic nature.